Hello and welcome to Astronomy Daily, your gateway to the cosmos. I'm Anna, and today we're exploring some fascinating developments across our universe, from our neighboring planets to distant galaxies. Coming up on today's episode, we'll venture to Mars, where the Perseverance rover has discovered diverse rocky outcrops on the rim of Jezero Crater, providing new insights into the red planet's ancient history. We'll also dive into some celestial mathematics to explain why Easter will come unusually late this year, despite the timing of the full moon. It's a fascinating intersection of astronomy and tradition. Then, we'll explore research suggesting that millions of interstellar objects from Alpha Centauri might be hiding in our own solar system, creating connections between star systems we never imagined. April is Citizen Science Month, and I'll tell you how you can join NASA's ambitious goal of achieving 1 million acts of science and become part of real astronomical discoveries. Finally, we'll witness the dramatic awakening of a supermassive black hole erupting with the most powerful X-ray blasts ever recorded, challenging scientists' understanding of these cosmic behemoths. So buckle up for a journey across the cosmos as we explore the latest discoveries and wonders of our universe. Let's get started with our favorite red planet. NASA's Perseverance rover has made a remarkable discovery on the rim of Mars's Jezero Crater, stumbling upon a treasure trove of diverse rocky outcrops that have scientists buzzing with excitement. Since January, this plucky little rover has been analyzing what scientists describe as a hodgepodge of rocks on the crater rim, and the findings are proving more valuable than anticipated. Perseverance has been working at an impressive pace, coring 5 rocks and successfully sealing samples from 3 of them in collection tubes. It has conducted detailed close-up analysis of 7 rocks while assessing another 83 from a distance using its laser technology. While this might not sound like a substantial workload over several months, NASA reports this has actually been the rover's fastest science mission since landing on the red planet in 2021. The rover reached the crater rim in December 2024 and has been exploring a 135-meter-tall slope that scientists have nicknamed Witch Hazel Hill. What makes this location so special is the remarkable variety of rock types found in close proximity to each other. Project scientist Katie Stack Morgan from NASA's Jet Propulsion Laboratory explains the significance. During previous science campaigns in Jezero, it could take several months to find a rock that was significantly different from the last rock we sampled and scientifically unique enough for sampling. But up here on the crater rim, there are new and intriguing rocks everywhere the rover turns. It has been all we had hoped for and more. The western rim of Jezero Crater features numerous fragmented rocks that were once molten. Scientists believe these rocks were brought to the surface by meteor impacts billions of years ago, possibly including the very impact that created Jezero Crater itself. One particularly exciting sample was collected on January 28th from a rock dubbed Shallow Bay. This rock likely formed around 3.9 billion years ago, potentially making it the oldest sample collected by the rover so far. About 110 meters away from Shallow Bay, another intriguing rock caught scientists' attention because it contains minerals that crystallized from magma deep within the Martian crust. These diverse mineral compositions are crucial for scientists attempting to piece together Mars's geological history. By analyzing these rocks, researchers hope to better understand how the planet formed and evolved over billions of years, including whether conditions were ever suitable for life to exist. The abundance and diversity of these rocks will help scientists determine if Mars was once habitable and if it might still harbor environments that could support life today. Each sample provides a window into different periods of Martian history and different environmental conditions. As Stack Morgan enthusiastically puts it, the last 4 months have been a whirlwind for the science team, and we still feel that Witch Hazel Hill has more to tell us. We'll use all the rover data gathered recently to decide if and where to collect the next sample from the crater rim. Crater rims, you gotta love them. If you've ever wondered why the date of Easter seems to jump around the calendar from year to year, you're not alone. Easter 2025 is coming particularly late, falling on April 20th, and there's a fascinating astronomical reason behind this mobile holiday. Easter's date is determined by what's known as the Paschal Moon, the first full moon that occurs on or after the spring equinox. In theory, Easter should fall on the Sunday immediately following this full moon. This connection between Easter and lunar cycles has ancient origins, linking the Christian celebration to the Hebrew calendar and Passover. In 2025, the April full moon, traditionally known as the pink full moon, will occur on April 12th. Despite its name, this moon won't actually appear pink. The name comes from the blooming of moss pink phlox flowers that typically coincide with this lunar event. Since this full moon happens after the spring equinox, it's also the Paschal Moon for 2025. Given this timing, you might expect Easter to fall on April 13th, the Sunday immediately following the Paschal Moon. However, Easter 2025 will actually be celebrated a full week later, on April 20th. This discrepancy highlights the complex relationship between astronomical observations and ecclesiastical rules. The explanation involves the difference between astronomical reality and church tradition. While astronomers calculate the exact moment of a full moon based on the moon's position relative to Earth and the sun, the church follows ecclesiastical tables that don't always align perfectly with astronomical events. Additionally, there's a geographical factor at play. In North America, the Paschal full moon occurs on Saturday, April 12th. But in European longitudes, including the Vatican, this same full moon happens after midnight, technically placing it on Sunday, April 13th. Since the first Sunday after the Paschal Moon in the Old World would be April 20th, that's when Easter will be celebrated globally. The rules for determining Easter's date have other interesting quirks. For instance, the Church fixes the vernal equinox on March 21st, even though astronomically it now falls no later than March 20th. This can lead to some peculiar situations. In 2038, for example, the equinox will fall on March 20th with a full moon the very next day, but Easter won't be celebrated until April 25th, the latest possible date it can occur. Easter can fall as early as March 22nd, which last happened in 1818 and won't happen again until 2285, and as late as April 25th. Interestingly, when Easter occurs in March, it's always preceded and followed by April Easters in adjacent years. Between 2000 and 7,999, Easter will fall most frequently on April 19th, occurring on that date 231 times. However, if we narrow our focus to just this millennium, April 16th becomes the most common Easter date. So when you mark Easter 2025 on your calendar for April 20th, remember you're participating in a tradition that blends ancient astronomical observations with ecclesiastical calculations, a fascinating intersection of science and faith that continues to evolve through the centuries. Next up today. Have you ever wondered if objects from other star systems might be passing through our cosmic neighborhood? A fascinating new study from Western University suggests that our solar system could be home to millions of interstellar visitors, primarily from our nearest stellar neighbor, Alpha Centauri. Astrophysicists Cole Gregg and Paul Wiegert have developed a groundbreaking computer model that simulates interstellar activity between our solar system and Alpha Centauri. Their research, published in the Planetary Science Journal this March, points to Alpha Centauri as a likely source of interstellar material found within our solar system. Alpha Centauri is particularly interesting because it's a triple star system, unlike our single sun arrangement. Yet the researchers believe it might behave similarly to our own solar system when it comes to ejecting material into space. As Greg explains, giant planets introduce a degree of chaos, perturbing orbits and giving objects the velocity boost they need to escape their star's gravitational pull. The model suggests something truly remarkable. Approximately 1 million interstellar objects larger than 100 meters in diameter originating from Alpha Centauri may currently be within our solar system's Oort cloud, that vast shell of icy objects surrounding our planetary neighborhood. And this number is expected to increase as Alpha Centauri moves closer to us, with its closest approach predicted in about 28,000 years. Assuming Alpha Centauri is ejecting material, which it should be, there are plenty of reasons to expect some of that material is making its way to us, notes Professor Wiegert, who has discovered more than 80 minor planets during his career. This research builds on our understanding of interstellar objects that began with the 2017 discovery of Oumuamua, the first confirmed interstellar visitor, spotted by Western scientist Robert Weirich. Oumuamua, a reddish object estimated to be between 100 and 1,000 meters long, was just the first glimpse of what could be a much larger population of interstellar wanderers. Before you worry about interstellar impacts, the researchers offer reassurance. They're model projects that, while as many as 10 meteors from Alpha Centauri might enter Earth's atmosphere annually, these would be microscopic, no larger than 100 micrometers in size. In fact, only about 1 in a trillion meteors striking Earth might originate from Alpha Centauri. The real significance of this research lies in how it transforms our understanding of cosmic systems. As Greg eloquently puts it, throughout the history of astronomy, every time we look at a system, we think of it as a closed system. The galaxy isn't a collection of all these individual star systems. Rather, they should be studied as an interconnected system, one that shares all of this interstellar material among the stars. This interconnected view of our galaxy challenges the traditional notion of star systems as isolated entities. Instead, it suggests a cosmic ecosystem where matter regularly travels between neighboring stars, creating a complex web of interstellar exchange that has been ongoing for billions of years. Next, something you may like to take part in. April marks a special time for science enthusiasts around the world. It's Citizen Science Month, and NASA is embarking on an ambitious mission they're calling 1 Million Acts of Science. This initiative aims to harness the collective power of volunteers everywhere to help solve some of astronomy's greatest mysteries. Citizen science represents a beautiful intersection of professional research and public participation. Through these programs, ordinary people like you and me can contribute meaningfully to scientific discovery without specialized degrees or equipment. NASA's citizen science projects are designed to address real-world problems, protect our planet, and unravel the secrets of the universe. The concept is simple, yet powerful. By distributing scientific tasks across thousands of volunteers, researchers can accomplish what would be impossible for even the largest professional teams. Your contribution, combined with others around the globe, creates a formidable force for scientific advancement. So what exactly counts as an act of science? It could be as straightforward as categorizing galaxies based on their shapes, identifying features on Mars, tracking changes in cloud patterns, or monitoring light pollution in your local area. Many projects require nothing more than a smartphone and a curious mind. What makes these initiatives particularly valuable is that they're not just busy work. The data collected through citizen science efforts has led to genuine discoveries and appears in peer-reviewed scientific publications. Your contributions help NASA scientists understand our changing planet, identify new asteroids, study distant galaxies, and monitor space weather. The beauty of citizen science is its accessibility. Projects are designed to accommodate various interests, time commitments, and skill levels. Whether you have 5 minutes while waiting for your coffee or want to dedicate several hours each week, there's a project perfectly suited to your availability. If you're interested in participating, NASA's Citizen Science website offers a comprehensive directory of active projects. From helping classify exoplanets to tracking wildlife responses to solar eclipses, the diversity of opportunities means you're bound to find something that captures your imagination. By joining this worldwide community of citizen scientists, you become part of something much larger than yourself, a global effort to expand human knowledge and address some of our most pressing challenges. And during this special month celebrating citizen science, your participation helps NASA reach that ambitious goal of 1 million scientific contributions. Remember, science isn't just for professional researchers in labs. It belongs to all of us. And through citizen science, we all have the opportunity to push the boundaries of human understanding just a little bit further. If you're interested in finding out more, I'll leave a link in the show notes for you. We've all experienced grumpy mornings, but nothing compares to the cosmic tantrum recently thrown by a supermassive black hole in a galaxy far, far away. Astronomers have observed something truly extraordinary. A monster black hole unleashing the longest and most powerful X-ray eruptions ever recorded from such an object. The black hole in question sits at the center of galaxy SDSS 1335 plus 0728, approximately 300 million light-years from Earth. After decades of inactivity, this cosmic giant has suddenly awakened with a vengeance, beginning to devour surrounding matter and producing what scientists call quasi-periodic eruptions, or QPEs. This active region at the galaxy's heart, nicknamed Ansky by researchers, first showed signs of awakening in late 2019. By February of this year, astronomers using NASA's Swift X-ray Space Telescope observed the black hole erupting with flares at surprisingly regular intervals, providing a rare opportunity to monitor a feeding black hole in real time. What makes these observations particularly remarkable is their unprecedented scale. As MIT researcher Yoheen Chakraborty explains, the bursts of X-rays from Ansky are 10 times longer and 10 times more luminous than what we see from a typical QPE. Each eruption releases 100 times more energy than previously observed elsewhere, with eruptions occurring roughly every 4.5 days, the longest interval ever seen. These extreme behaviors are challenging existing scientific models and forcing astronomers to reconsider their understanding of such events. Typically, QPEs have been associated with supermassive black holes capturing and shredding stars, then consuming the stellar remnants. However, this doesn't appear to be happening with Ansky, leaving scientists puzzled about what's triggering these massive outbursts. The observations were made possible through an international collaborative effort utilizing multiple space telescopes, including the European Space Agency's XMMM Newton, NASA's NICE and Chandra missions, and archived data from Erosita. These repetitive bursts may also be generating gravitational waves, ripples in space-time that could potentially be detected by future missions like the Laser Interferometer Space Antenna, a joint ESA-NASA space-based detector scheduled for launch in 2037. Having complementary X-ray observations alongside gravitational wave data could prove crucial in solving the mysteries of massive black hole behavior. The research on this extraordinary cosmic event was published in the journal Nature Astronomy just last month, marking an important step forward in our understanding of black hole dynamics. As astronomers continue monitoring Ansky's volatile behavior, we may gain valuable insights into the extreme physics governing these cosmic behemoths that lurk at the centers of most galaxies, including our own Milky Way. And that brings us to the end of another fascinating journey through the cosmos. Today, we've explored everything from Martian geology to the mysteries of black holes, with some interesting astronomical calendar facts and citizen science opportunities along the way. We've seen how Perseverance is uncovering Mars's geological history through diverse rock samples on the Jezero Crater rim, potentially revealing clues about the planet's habitability. We've demystified why Easter will arrive later than expected this year, thanks to the complex interplay between astronomical events and ecclesiastical rules. We've learned that millions of interstellar visitors from Alpha Centauri might be hiding in our solar system, challenging our view of star systems as isolated entities. We've discovered how you can participate in NASA's Citizen Science Month and contribute to their ambitious goal of 1 million acts of science. And finally, we've witnessed the dramatic awakening of a monster black hole producing unprecedented X-ray eruptions that are forcing scientists to rethink their understanding of these cosmic giants. I'm Anna, your host for Astronomy Daily, and I hope you've enjoyed today's cosmic exploration. If you'd like to stay updated on all things astronomy, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and access all our previous episodes. If you're enjoying the podcast, we'd be thrilled if you'd share it with your family, friends, or anyone else who gazes up at the night sky with wonder. Until next time, keep looking up and stay curious about our magnificent universe.